Hello students, I believe that you are learning this topic moments quite well because we are on question number 4 now. This is your past paper AS Physics question. As I always say, take a moment to pause the screen, try to solve the question yourself, come back, play the video again to look at the working of it. So this is the first screen of this question, and here you have the second screen. I am just waiting here for a moment so that you can pause the screen here as well and solve the second part of the question as well. Meanwhile, please do not forget to subscribe to the channel and like the videos which you are watching, because it is highly encouraging and highly rewarding to see some inputs coming from your end. And also please do not forget to comment in the comment box if you have any doubts or if you want to discuss on any particular query. Alright, so I believe that you have solved the question. You're coming back and playing the video again. So let us understand what question number first is saying. To explain what is meant by the center of gravity. Simple and easy to say. It is a point from where you can consider the entire weight of the object to act, right? This is some of the simplest thing to define. Point where the weight of an object may be considered to act. This is a 2-mark question. Easy to score. Define moment of a force. Now please do remember, how do you write moment? It is simply the formula of the moment, product of the force and the perpendicular distance to the pivot. Perpendicular is a key term. If you do not mention the term perpendicular, you will not get that 1 mark which this question is carrying. So be careful, include the term perpendicular. Alright, so let us move on. A student is being weighed. The student of weight W stands 0.3 meters from the end A of the uniform plank AB as shown in this figure. So let us identify where is the plank. The information which is given in the question, let us try to locate all the information in the picture. So A and B is the plank. This is the student who is at an end at a point which is 0.3 meters from the end A. The plank has a weight of 80 newtons. Where is 80 newtons? Here, if you see, it is coming from the center of the plank, and a length 2 meters. It is also marked in the question. A pivot P supports the plank and is 0.5 meters from the end A. So this is, where is the pivot? Try to locate it. 0.5. This point P is the pivot. A weight of 70 newtons is moved to balance the weight of the student. The plank is in equilibrium when the weight is 0.2 meters from the end B. Which weight they are talking about? This weight. When it is 0.2 meters from the end B, everything is in equilibrium. State 2 necessary conditions for the plank to be in equilibrium. Now this is a question which keeps repeating whenever you have a question on moment. This is a question which has a 90% of chance to come in the paper, and this is what we have been seeing coming again and again in each of the questions that we have been solving so far. 2 conditions necessary for an object to be in equilibrium. If you are not comfortable with this, I am again including the link, the theory for the equilibrium video link in the description box. Check it out. So what are the 2 conditions? Resultant force should be 0 and the resultant moment should be 0. Let me type it out here or write it here. What are the 2 conditions? Resultant force, or you can say the net force, 0, and the resultant moment is 0. Resultant moment as 0 is the same thing as saying clockwise moment should be equal to anti-clockwise moment. It's the same thing, right? Even if you are saying clockwise moment should be anti-clockwise moment, it means that the resultant moment is 0. Why? Clockwise moment should be equal to anti-clockwise moment. If you are saying this thing, what does it mean? Clockwise moment, if you are taking this thing on the same side, minus anti-clockwise moment is 0. What do you see? That the resultant of clockwise and anti-clockwise moment, when you take the resultant, because they are in the opposite direction, there is a subtraction sign coming in between. The resultant of clockwise and anti-clockwise becomes 0. This is what it means. The resultant moment is equal to 0. Alright guys, let us move on to the next part of the question, which is also simple. Determine the weight of the student. I've carried the picture on this screen as well. Determine the weight. P is the pivot, so let us take, there is only one missing variable, so you need not worry. Let us first make a circle around all the forces so that we do not miss on any force while calculating the moment. So this is the force, this is the force, this is the force. Is there any other force that you can see here? So you have to find the moment of 3 forces. Which ones are creating clockwise moment? Let us mark them with the blue color. Clockwise and clockwise, they'll add up. Which one is creating the anti-clockwise moment? It is just the weight. So let us write it down, saying that anti-clockwise moment should be equal to clockwise moment. Please, in your notebooks, you will not write in the short form, as I keep telling again and again. You are students, you'll have to write it everything in expanded form. I am a teacher, I'm explaining you. As long as you understand the short form, I prefer to write in the short form to save your time and my time as well. So what is anti-clockwise moment? Because of the weight times its distance from the pivot will be how much? 0.5 minus 0.3, easy calculation, so it is 0.2. How much is the clockwise moment of this force 1, which is 80? So 80 times its distance, this distance. How much is this distance? Half of 2, 1 minus 0.5, because this is your 0.5. So this is 0.5 plus the moment of 70 times its distance from the pivot. How much is this distance? This would be this, okay, 2 minus this much and this much. So 2 minus 0.7, 2 minus 0.7, so which becomes 1.3. 1.3. Are we doing everything correct? We'll tally with the mark scheme, but I'm sure now you can solve this. It's an easy calculation that can be done mentally as well as on your calculator, whichever way you want to prefer. Please solve it out. You can pause the screen here for a while. I'll now show you the mark scheme. See, everything is the same. So that means we are going the correct way, and your answer should be 655 newtons. So if you are wondering why I'm not doing in the calculator, it is to save your time only, because the only thing which is left to do is the calculation, which you all are expert in doing. Now the next thing that I'm leaving it on you is the IGCSE kind of question, which is question number 3. Please read this question and try to attempt this question yourself. It relates to very simple fundamentals of moment, which relates to the understanding of that if you increase the distance from the pivot, the moment increases, right? So please attempt it yourself and see if this makes sense to you. If you still have queries on this question, I would like to hear about it in the comment section, and then we can have a discussion there in the comment section about it. This is your mark scheme. Please read the mark scheme as well, especially for the last part, which you're going to solve yourself. So this is your self-study work, which I'm leaving it on you. So the next question will be on question number 5, moments again.